That's my Twitter account. If you want to connect with me post this session, you can just reach out to me over there, or else probably you can just reach out to me on LinkedIn. That's where I'm most active. So let's get started. So this is what we're going to talk today. We are going to kickstart the conversation by discussing what event-driven solutions are. Then we are going to have a look at the evolution of application hosting platform. Then we are going to understand what is serverless. Well, obviously we have talked a lot about serverless, so I expect everybody of you to know what it is and answer. The next thing would be, what is Azure Functions? Let's not discuss more about it. Probably we'll discuss at the right time when the deck comes. Secondly, we are going to talk about what is IoT Hub. Then we're going to understand what Cosmos DB is, and then we are going to use all of these things to build a solution. So are we all ready? Yes. Great. So let's get started. Now, what are event-driven solutions? We had a lot of session today who told about event-driven architecture, solutions, and all. Anybody in the crowd who would like to say what event-driven solutions are, or give me some examples? Anyone from the crowd?
So the solution which the different components are connected with each other via events. Right, so one component sends an event to another, and then that component processes it, sends it to another server, or probably we have to give response back. It will trigger in another event to response back. That's an event.
That's an interesting answer. Anybody else would like to give an answer? The mic is all yours if you want to answer.
I have been working on IoT since like 2017, and that is the base example of event-driven, I guess, because collecting data from the sensor and using the RabbitMQ or ActiveMQ, publishing and subscribing, and then sending data to cloud, doing the manipulation of the data and doing data to the end customer on the dashboard. So who is the pattern, right? It's all about event, because some of the sensors might collect data on trigger base, right? Some of might get on time, so that is hard.
Well, thank you for the answer and mentioning about an IoT solution, because at the end of the talk, this is what we're going to build. So I hope you're looking forward to that. So event-driven solutions are anything which get triggered on the basis of an event. This event can be anything. It can be a response, it can be a request which is sent to a webhook, or maybe every time you upload a file to a blob storage. Just for people who are not aware with Azure, blob storage is like a similar offering of Microsoft Azure to what AWS S3 bucket is. So every time you upload a file over there, you want to trigger something, then probably you can build an event-driven solution using Azure Functions or Logic App to do that. So now that we know what an event-driven solution is, let's have a look at the evolution of application hosting platform. So usually whenever I give a talk around Azure Functions, I have this deck, irrespective of the fact whether it is a technical one or a functional one. So my friend Jamie over here did give up good numbers. He showed the numbers over there, how the cloud adoption happened, what are the advantages, disadvantages. I have a different approach of conveying this message, in which I talk about the evolution of the application hosting platforms by taking an analogy in which I usually travel to places and how I prefer to stay. So I came here all the way from Hyderabad, and I want to stay here for one day because I came yesterday. I have to stay in the night somewhere, right? So what would be the ideal option for me? Is it buying a mansion and staying here just for a night? No, right? So that is what on-prem was. So we were basically buying all the resources that we needed. We had to buy backup servers so that, just in case you have more load, you get more traffic, you have a lot number of users getting into your system and want to leverage your services. You want to be available to cater their requests. So we used to have this bottleneck in which we had the ownership. We had to buy things. We had to manage these things. Every time you have a server, you'll have to patch it. You'll have to ensure that they are running well. You have to ensure that they get an uninterrupted power supply, UPS. So you do all other bottleneck things, right? Do you want to do that? Just because you're coming to Ahmedabad, do you want to buy a mansion and take the hassle of buying a property, doing all documentation, all this stuff? No, right? There are better approaches. There are better way of doing it. What can be better? Is it renting the mansion? Can be better than buying it, right? I don't want the ownership, but I definitely want the luxury of the mansion. But with renting it, I need to make sure I have a security guard in place who is guarding my house. I need to ensure that there are proper housekeeping staff who are going to clean my house, they're going to maintain everything, and I want somebody who's going to cook it, who's going to maintain the kitchen and everything. That's what happens. I do not have the ownership, but now I still have to maintain certain set of things that happens around with that, right? That comes out of the box when you rent anything. So similar to that, with infrastructure as a service, though you do not have to buy the service and you can get the service on demand whenever you want, you still have to patch the operating systems into patch your software with the latest updates so that you do not have the bugs and all the security vulnerabilities which my friend Thawal had previously highlighted. And one other speaker who was talking about the security concerns that can arise while you're building serverless solutions. So you need to be, very cautious about things. So now we still have to ensure that we get the regular updates. We need to design it in a way that it scales out whenever we need. For example, I can rent one mansion, but if I need more, I'll have to rent another one manually, right? Nobody's going to do it for me. So these are some of the challenges that came with infrastructure as a service. Now, can we get a better solution than this? Well, we can. I just want to stay here. I want my work done. I can rent a flat, right? It's economically cheaper, it's more efficient, and whenever I want, I can do it, and I do not have the hassle of maintaining a big house. Similar to that, PaaS. With PaaS, you get the luxury of not worrying about the entire infrastructure resources that you provision when you want to deploy your application. You do not need to worry about the patches and all those stuff. You just select a runtime, you define the scaling rules, like when you want to scale in, when you want to scale out, and probably you're good. There are some monitoring things that you'll have to do, but that comes, as an ad hoc item that you will have to do anyways, right? Now that is PaaS for you. This was really nice, but there was one bottleneck. The bottleneck was you'll have to pay upfront, right? You'll have to pay for a certain amount of compute size that you consume. In Azure, we deploy these things in Azure Web Apps. There is an ACU that you predict and say that, okay, my application is going to need this much amount of compute, so this is what I'm going to pay for the month. You had predictable billing and all, but even if your application doesn't run, you're paying money. And where do you get the money? If your application is not being used by your customers, how do you generate revenue? If you have no revenue, how are you going to pay? Now, how do you tackle this problem? This is the solution for you. Well, renting a flat would have been great, but I'm just there for a night. I have no friends coming over. I do not need such a space. I do not want to be consuming everything. And with rent, you get this rent agreements, right? So you stay or not, you have to, if you leave within 2 months or 3 months without giving notice, you'll have to pay the money. Similarly, in Azure, when you use an app service, you're paying monthly charges for the time that you're using, even if your application is running or not. So with this flat also, even if you stay, you don't stay, you'll have to pay the monthly rentals, right? But what if you book a room in a hotel? Isn't it more efficient? You just pay 800, 700 rupees, don't need to worry about the entire thing. You have housekeeping who's going to come and clean your entire room, do all the stuff for you. Ring a bell and you get your lunch and dinner. Isn't it fun? Isn't it good? Well, that's what serverless is. So now you need not worry about all the underlying infrastructure jargons or the details that you had to worry about in the previous things. You don't need to worry about the scale in rules, scale in and scale out rules. You can just focus on writing the business logic. Just like Prashant mentioned, I don't want to get into the rabbit holes. I just want to focus on the things where I get business value. So now as developers, we can focus on writing the actual business logic, which can create an impact instead of worrying about all the underlying things, which may not directly generate any business value for us. So you write functions, you deploy it as units, and you get it up and running. This will basically function as microservices, and with this, you get a pay per action per second billing. So if you're not using it, your application is not in use, you're not paying any money. So basically, you're doing more with less hassle. So what is serverless? We talked about the application hosting platform, we talked about serverless and how it all evolved. Now I want somebody from you to say what serverless is. We had some amazing speakers who talked about it throughout the day. Now I want to know your opinion on that. Anybody wants to say anything about serverless? What serverless is according to you?
So actually, serverless is a kind of technology, or we can say change, in which the one who is needed, if I need to use a server, then I would, I am not supposed to purchase servers and manage it, but someone else would manage it in behalf of me. And all these things run on, just I can just see in my small computer, and all these things run on it. So this is the best I can define.
Wonderful. Thank you for sharing your thoughts. Anybody else who would like to share their opinions on serverless?
It's a push to use the cloud services without thinking about the scaling those services as required.
Interesting. Any more? Any more opinions from this side maybe?
Forget the hardware, forget the OS, forget all about simplified just code and no need to worry about the underlying layers. And that's
Well, these are some interesting answers, and I think the audience has actually, absorbed all the knowledge that our distinguished speakers have shared with them, imparted their knowledge with them. So, I think we had a productive day today. Everybody learned something. So, according to me, a serverless solution usually consists of 4 things. One is it should be stateless. Like any action should not be dependent on the previous action or the data that it generates. Second would be it needs to be event driven. Something needs to trigger it because it's not running all the time, right? Something must trigger it. An event can be anything, just like we discussed previously. A webhook or file upload or maybe a timer. Can be anything, right? Second thing is it should have micro billing. That's what serverless is, right? You want to pay for the time that you're using. The third is abstraction of service. Just like the gentleman over here mentioned, people often think that serverless means no service. Well, that's a pretty vibrant misconception that people often have when they hear about serverless. It's usually less service. Servers are still there, but there's an abstraction that's created, and there's an cloud service provider who is managing it for you. It can be Azure, GCP, AWS, anyone, right? But still, the hardware are there, sitting in a data center somewhere. But some people have been smart enough to build a software in which we can click few buttons and it can provision it, and as and when needed, this scale out to multiple instances and cater our requests. Now that we have a clear visibility of what Azure Function is, let's understand what Azure Function is. So Function is built on top of all the features that I mentioned that a serverless solution has. Apart from that, it is a function as a service offering of Microsoft Azure. So what is a function as a service offering? So how many of you know about FaaS? Raise your hands. Okay, that's a good number. How many of you know about AWS Lambda? Oh, a lot more. So AWS Lambda is a FaaS. So probably people, you all know what FaaS is. So comparative product is Azure Function. So in this service, what you do is you write your business logic as small functions and deploy as small chunks of code, which serves a particular business functionality. It is very much similar to what a microservice might act like. So this is what Azure Function is. It usually comes with a certain set of things, like it has a trigger. You need to define what kind of trigger should run this particular code, right? So in Azure Function, you have multiple sort of triggers, which can be blob trigger, a Cosmos DB trigger, an event grid trigger, or maybe event hub. There can be many. I don't. How many of you have previously used Azure? Can I just do a health check on that? Just seeing how many of you know. Oh, great. It's glad to know that some people know. Yeah, jokes apart, but yeah. So there can be multiple triggers, HTTP, schedule, there's so many. We are going to discuss about one of the triggers. Now there's one more component to Azure Functions, which are bindings. So what are bindings? Any idea? So bindings are a declarative way of accessing a data source or maybe writing into something. So there are two types of binding, input and output. As the name suggests, inputs lets you get some resources from a data source. For example, every time your function runs, you want to get some amount of data to process it. Thus probably when you want to use an input binding, it will be saved from all the effort that you would have to do to write all the boilerplate code to configure the SDKs. So SDKs are nothing but packages for people who are not .NET developers. Okay, how many are .NET developers? Good, good. So Nugget packages are something similar to Python packages, okay, or Java files. So it's something similar to that. So every time you want to, let's say, consume anything of an SDK or a Nugget package, you'll have to create an instance of it. Then you need to call that particular method. Then you need to pass on the parameters and do it. So there's some amount of boilerplate stuff that you all do. Now with these bindings, you do not need to do that. You just need to specify a couple of parameters and you get all the data. Similarly, if you want to write something, you need to use the output binding. So that's the crux of the thing. I think that's a lot of information. Let's go on to the next component. As I told you in the initial section of the presentation that we are going to use 3 services: Azure Function, IoT Hub, and Cosmos DB. We have covered Azure Functions. Let's understand what IoT Hub is. Anybody would like to share what they think IoT Hub can be? Anyone? No one? Okay. You want to say? Yeah.
Service to provision the devices.
That's an interesting answer. There's one more gentleman who would like to share his opinion.
Service that processes. Okay, a service that processes IoT data sent from IoT devices.
That's an interesting answer. Anyone else? Okay, probably in the interest of time, probably we'll just take that many opinions. So it's a fully managed solution offered by Microsoft Azure. It runs as a serverless as well as a PaaS offering. So as the gentleman shared over here, it helps us provision devices. When you say provision, it helps in registering device with the service because the device is already there. That's a hardware, right? Second thing is it helps us authenticate whether the device is allowed to send the data to the IoT Hub or not. As the gentleman with the black shirt over there mentioned that it stores the data that is sent by the devices. It does so till the time a consumer comes into the picture. Now it stores metadata of a device as well. Like some of the devices are meant for certain certain kind of problem statements to solve. It can be related to a particular unit, maybe. A company can have multiple units and they can have a large amount of IoT devices. Some are only meant for certain units to use and not for the others. So you can create those kind of segregations, add additional information using the metadata. Second, it allows you to connect with the IoT Hub using different communication protocols like AMQP, MQTT, HTTPS and all. So it provides the support for all because these edge devices or IoT devices, they connect over different protocols. Not everyone supports HTTPS, right? Because not every device can directly connect with an internet. You have a Bluetooth device, that's also an IoT device, but it needs a field gateway to connect with the internet to communicate, right? So it also provides you client and cloud SDKs. You basically use the client SDKs, or these are basically packages in Python, Node.js packages, and Java jars. So you use this client SDKs to communicate with the IoT Hub. Let's say you want to send some data, you want to get a firmware update or anything, you get it by making a call to the IoT Hub to extract those information from the IoT Hub instance. Now the cloud SDKs are basically used when you want to, let's say, register a new device, or let's say you want to renew a certificate of a device, or let's say you want to maybe push and firmware update back to the IoT device. So these kind of things, you basically use the cloud SDKs. It provides first-class integration support for different Azure services like Logic App, Functions, Event Grid, Event Hub, Service Bus, and all this stuff. So you might wonder why do I need to integrate? Basically, you have the data, right? So you have a device which is generating data and dumping into a message store. So IoT Hub is basically a message store in which you're dumping all your telemetry data. And now you want a listener or a consumer to process it. So the device is a producer. You have your events in a data store. Now you want to process it. And who's going to process it? It can be anything. It can be a stream analytics job. It can be, maybe forwarding to a different queue to store. Or it can just be consumed by a function app to do some amount of information, some amount of thing. So that's all about IoT Hub. Let's understand what Cosmos DB is. I'm giving you a very high level overview because the time is very limited. I understand it can be pretty overwhelming to get everything. So let's try to understand what Cosmos DB is. So Cosmos DB is a fully managed NoSQL database, a probable equivalent of DynamoDB. Now it is highly scalable. It offers you, single-digit millisecond response time. Comes out with enterprise-grade security. Suppose multiple APIs. When I say multiple APIs, it means that let's say you are a NoSQL developer, you use different kind of databases. Somebody can use MongoDB, somebody can use Gremlin, somebody can use Cassandra. They are basically for different purposes. So let's say you want to move your databases over here, or you want to create a greenfield application, but your team is more, comfortable with certain way of writing things. Then you have the certain set of APIs that you can use. But the recommendation is probably to use a core SQL API if you are starting a greenfield development and you want to leverage Cosmos DB. Because with core SQL, you basically get a SQL-like query structure in which you can just write some SQL queries and get the results set. You don't need to have knowledge of MongoDB or anything to manage your NoSQL databases and access it from your applications. Now, we know the three components that we are using today. Now what we are building. So as my friend Dhaval mentioned, that you should not be building things because just it's there. You shouldn't be using services. Now understand, why did we just talk about these three specific services and not anything else? So basically, we are working for a fictional company, and you are an aspiring, aspiring freshman there, who just started his career. He's really enthusiastic, and he wants to build things. He wants to build the innovative thing. He does not want to do the support and all the stuff that usually, freshers are assigned, because that's probably the easiest one to do, and they can learn a lot about the business of the application that they might get an opportunity to build in the coming days. So this guy was really passionate, and it was a small company. The CEO noticed it, and he said, hey, we want to build something. We want to build a capability where we want to, get telemetry information, which are basically health data from a patient, from a device, and it should be processed and then stored in a persistent storage somewhere. And he was tasked to build it using Azure because let's say that they have some Azure cloud credits that they want to consume. So they gave them the access to build the capability, and this gentleman, this friend of mine who is a freshman, he explored various options and he shot it down to these three things to build the bare minimum proof of concept to showcase capability. Now, the ask was a mechanism to store health data about a patient generated from different sensors. Now, what all things do you think we need? Anybody from the audience who would like to share? What can be the thing that we need here? Well, I see a lot of blank faces, so probably I'll directly jump to what all components we might need. Just like any other typical IoT solutions, we need a device which is generating data. We need a processor. Okay, probably we can take it at the end. So just like any other IoT solution, we need a device which is sending data basically, right? Second thing is, now the data is generated. We want it to store somewhere so that we can consume it later. Now the data is there. So we are using an IoT hub to store the data. We will use a mock data simulator in our scenario because I do not have the hardware and I did not have the budget to do it. So you can, if you have the budget, please have an Arduino or a Raspberry Pi where you can, build this thing. The code would run either ways. So you need a mock data simulator to simulate the data that is generated. Then send it to IoT hub, which will act as a data store. Now you want to process it. How are you going to process it? You're basically going to use Azure Functions, which is going to run on an event or a trigger every time a message comes to this IoT hub. And once you have created an IoT hub, what do you need to do? Not any IoT device can send data to this IoT hub, right? You'll have to register it. So the next thing would be, that comes, but before that you need one more information. That is the event hub compatible name. So this is basically the event store where your data is going to be stored. And the third thing would be the built-in endpoint for that. So you basically, so every time you want to process some data from somewhere, right, you need to have a connection string and the queue name from where you want to process it, right? So this is the information. And where will you get it? You'll get it from the built-in endpoint section. From there, you can take the Event Hub compatible name, and the second thing would be the Event Hub compatible endpoint. And once you have these two information, store it somewhere. We're going to use it later. The next would be registering a device. Now, how will you register a device? You can go to the device management section. There you will see an option to register a device by clicking on the devices. Then click on the add device button. Here you can fill in the information that is required and you can add a device. So you'll have to fill in this information. You can specify what the authentication type is going to be. It can be key, it can be certificate. Best practice is certificate. For demo purposes, we are using symmetric key. So once you do that, you'll see the device over here. Then you can extract the device connection string from here and then use it in your mock data simulator as the connection string. Now, we have our IoT hub configured. We have the endpoints that we need. We have registered a device. We got this connection string. What else do we need? Well, we basically want to store the data, right? And where we are going to store it? In a Cosmos DB. So the next logical step would be to provision in Cosmos DB. So just like how we did it with IoT Hub, you're going to create an Cosmos DB instance, which is very standard. Go to Azure portal, search for Cosmos DB, click create, configure all the options, and then just click on review plus create, and it will provision something like this. Then you need to go to the data explorer and create a container. So this container is basically like your your table. So you'll have to create a database. I have created a database called serverless days. I have taken it as a serverless mode. I did not specify the throughput. So Cosmos DB also has a serverless option, FYI. Now you need to specify the container. You'll have to specify the partition ID. I have specified the partition ID as the patient ID over here. And I created a table called patients, which is basically going to store this information. Now we have created the basic bare metal thing that we want on the DB side to store this information. Now how do we access this database? You need the connection string, right? How are you going to connect with it? So the next logical step is getting the connection string for the Cosmos DB. How will you get it? Go to the settings, go to keys, then copy the primary connection string. So using connection string is not a best practice. Probably you need to use manage identity. I'm highlighting that, but for demo purposes, we are using this. So Cosmos DB ready, IoT Hub ready. What's the next step? The next step is creating our mock data simulator. We want a device to send the data first, right, before we process it. Our function may be ready, but it's not getting triggered because we have no data there, correct? So the next logical step is creating the mock data simulator. So I'm creating a console app over here, which is going to iterate 10 times to send 10 messages using some random data to this device. So the code would look something similar to this. I hope the code is a bit visible. I plan to add an interactive session where we can have, we can code directly, but due to some limitation, I had to put it up here. If it's not visible, I'm going to share the deck with all of you, and the team probably can share it with you all. So we are basically trying over here to send 10 messages using the device client of Azure IoT Hub, and then we are sending it every second for the first 10 seconds. 10 messages for in a gap of 6 seconds. So don't worry about this one. So that's the crux of it. Now the mock data simulator is ready, right? So this is the code that you need for that. I can definitely explain it. Like the send message is basically generating some amount of data using the data model over there, which is our health model, which consists of 3 properties, which is your pulse rate, SpO2 value, and the temperature. You generate some random data using one more method over there, which is basically going to generate some random value, and then you use the send method of the device SDK to send the actual messages, this mock messages that we have, to the IoT Hub. And once you send it, it goes to the Event Hub compatible name that we got from the IoT Hub. So this is about sending the data. I know it's a lot of information for you to digest in such a short time, but we are already running out of time. So the next logical step would be to creating an Azure function to process the data. So we have mocked the data, we have generated some amount of IoT messages or telemetry messages from our console app. Now we want to consume it. How we are going to consume it? So the way we wanted to consume it is an Azure function. So this is going to be an IoT Hub triggered Azure function, which is basically going to trigger every time a message gets into the IoT Hub. Now it needs some amount of information. I hope this code is visible. So you see over here, after public void run, you mention something called IoT Hub trigger. And then I say that you need to put your event hub compatible name over here. So in the provisioning and IoT Hub slide, I mentioned that we need two information: the built-in event hub compatible name and the endpoint. So you need to put the compatible name over here. Event hub compatible name is basically telling him this is the queue which you need to look into. This is where all your telemetry data is going to come. And then you have one more property called connections, which specifies IoT Hub con. So IoT Hub con is nothing but a configuration in your app setting.json. You just need to specify it over there and take, put up the built-in endpoint name over there that we got from IoT Hub, and it's basically going to subscribe all the messages, and each of the event that comes in are going to come from the parameter string message. So it's going to come in a string format. Now you need to deserialize when your function comes. So if you see over here, I'm deserializing using the Newtonsoft JSON library. I'm deserializing that object into a health model. So basically the health model is bottom there, which has an ID, pulse rate, temperature, and recorded it. And now we are using the Cosmos output binding. So if you see below connections, there's a Cosmos DB section in which we declaratively say what the connection string is, what basically is the DB name, what is basically the container name. So we are specifying it in a declarative fashion over there. We do not need to write any boilerplate code to write a data or write a document into Cosmos DB. So we just say, okay, this is the Cosmos DB. We want to use Cosmos DB. The database name is serverless days. The container name is patients, and the connection string that you need to use from the appsetting.json or from our secrets is basically Cosmos DB con. And then what it's going to do is that it's going to create an object, and whenever you write it over there and you use the document out.add async, it's going to asynchronously add the document in the Cosmos DB and write the data over there. So that's the crux of the function. It gets the data, it subscribes to a particular event hub compatible name of the IoT Hub, picks the data, deserializes it, then creates a document and stores in the Cosmos DB. So that's all the line of code that we needed to get a message from a device, get it to an IoT Hub, and then process it and store it in a Cosmos DB. If you want to do any other operations in between, like sending alerts or anything, you can put your conditional logics over here, before or after, depending on your business requirements. And that's how easy it is to build a real-time IoT solution. Now let's look at the demo, how it would look like. We had the code, and I need to make you people believe that it actually works, right? I cannot say, you cannot take me on my word. Let's see it. So now you see the Cosmos DB instance is completely empty. The container does not have anything. So let me go ahead and start boot my project. So it's going to start both the mock data simulator as well as the function app. So you see the mock data simulator now sending messages. It's going to send in messages. Message 1 delivered, 2 delivered, 3 delivered. I have intentionally kept a 1 second delay so that we can see that, okay, all the messages are going sequentially. So once 10 messages are gone, we're going to switch over to the function app runtime, the Azure function runtime tool, where our functions was running locally. So you see over here, we had 10 messages that were processed. They were deserialized, and we just sent it out. Now, there are some sequence ID and things, but forget about it. Don't really bother about the details. But here we see that we had some amount of logs where we saw all the telemetry data. And now when we refresh our container in Cosmos DB, you have the data over here. So the code actually works. I hope the session wasn't really fast-paced, and just wanted to call out about my recent book, Developing Cloud Native Solutions with Microsoft Azure and .NET. If you want to know about building cloud native solutions with Azure and .NET, probably you can have a look at my book. This is the link from where you can get it. And thank you for being an amazing crowd, Ahmedabad.